Hello, welcome back. Today we're going to be graphing linear inequalities on a coordinate plane. The objective is by the end of this video, you should be able to graph an inequality such as 3x minus 2y is less than 4 on a coordinate plane. Here are the steps I'm going to be going through in order to graph the inequality on a coordinate plane. You'll notice that these steps look a lot like the steps to graphing a regular equation in slope-intercept form. The first thing we need to do is to get y by itself. The inequality will then look like y is less than or equal to mx plus b, or y will look like y is greater than or equal to mx plus b. In other words, we'll have y and then a symbol, and then our slope, which is m, times our variable x plus our y-intercept. Once we get the equation in slope-intercept form, we plot our y-intercept. Then we plot 4 more points, 2 before and after the y-intercept, using rise over run, or m. Then we graph the line. Now here's the weird part, the part you have to know, the part you need to have memorized. That if y is greater than or y is less than, we use a dashed line. The reason we use a dashed line is because that tells us none of the points on the line make the inequality true, because it's not or equal to. However, when our inequality has the or equal to sign in it, we use a solid line to indicate that the line is included in the inequality. The points on the line do make the inequality true. Then we're going to shade above the line if y is greater than or equal to, because all of the points above the line if y is greater than or equal to will make the inequality true, and we shade below the line if y is less than or equal to. For our first example, I'm going to graph 3x minus 2y is less than 4. To do this, I need to get y by itself so I can get the inequality in slope-intercept form. I'll go ahead and rewrite the inequality right here to give myself more room to work. First, I'm going to subtract 3x from both sides. Undoing operations in set-map order, I subtracted first, leaving me with negative 2y is less than negative 3x, we always write our x term first, plus 4. We now need to get rid of the negative 2. To do that, we divide by negative 2, which means we divide all of our terms by negative 2 on both sides, leaving us with y. Since we divided both sides by a negative number, the inequality symbol flips, is greater than positive 3 halves x plus 4 over negative 2 is a minus 2. Now I have my inequality in slope-intercept form. All I need to do is go ahead and graph the line by plotting the y-intercept first. My y-intercept is negative 2, so I plot negative 2. My rise over run is 3 over 2, so I'm going to go up 3, 1, 2, 3, to the right, 1, 2. Up 3, 1, 2, 3, to the right, 1, 2. I can also go in the opposite direction to find 2 more points. I can go down 1, 2, 3, to the left 2. Down 1, 2, 3, to the left 2. Now there's a couple odd parts that separates an inequality when we graph it from a regular equation. One of them is if y is greater than, go back to your notes, then we use a dashed line. We use a dashed line to indicate that all the points on the line are not solutions to the inequality. The other weird thing is that we graph all of the points that are above the line. We shade all those points in because y is greater than, we shade above the line. That indicates that all the points above the line are solutions to the inequality. So again, when y is greater than, we shade above the line. When it's not equal to, we use a dashed line. Here are a couple of examples for you to try. Please go ahead and pause the video, work the examples out on your own, and press play when you're ready to see the answer. For the first problem, you should notice that the y is on the wrong side. If you want to, you can go ahead and just flip the entire inequality around, which I'm going to go ahead and do now. 3y minus 6x. Notice the greater than symbol, or the greater than side, points to the 3y. That means the greater than sign needs to be pointing to the side that has the y on it. So greater than or equal to negative 3. Now I need to get y by itself, so I'm going to add 6x to both sides, leaving me with 3y is greater than or equal to 6x minus 3. I then need to get y by itself by dividing every side, or everything on both sides, by a 3. This gives me y is greater than or equal to 6 over 3, which is 2x, minus 3 over 3, which is minus 1. I'm going to go ahead and plot the negative 1, which is my y-intercept. My rise over run is 2 over 1, so I'm going to go up 2, 1, 2 to the right 1, up 2 to the right 1, or down 2 to the left 1, down 2 to the left 1. Now since my inequality symbol is greater than or equal to, I'm going to use a solid line to connect the points, indicating that all the points on the line are solutions to the inequality. Since y is greater than, I'm going to do like I did in the last example, and I'm going to shade above the line, indicating that all the points above the line are solutions to the inequality. Here's the second example I asked you to work out. For this one, we're going to subtract x from both sides, leaving us with negative 2y is greater than negative x minus 1. Then we're going to divide all the terms on both sides by negative 2, leaving us with y is less than negative x over 2 is a positive x over 2, minus 1 over 2 is a plus 1 half. We're going to put a 1 in front of the x, indicating that our rise over run is 1 over 2. We plot our y-intercept first. Our y-intercept's 1/2, which is a little bit weird, but that means we just plot halfway between 0 and 1. And we're always going to count by the middles now when we go up. So our rise is 1 over 2, so I'm going to go up 1, which means I go to the middle again, and then I go right 1, 2. I go up 1 to the middle again, and then I go right 1, 2. Or I go down 1 to the left 2. Down 1 to the left 2. Again, I'm always going to the middle of the points since I started at a half. Since y is less than and not or equal to, I use the dashed line to indicate that the points are not solutions to the inequality, the points on the line. Since y is less than, I shade below the line, indicating that all the points below the line are solutions to the inequality. There are a couple of special examples you need to know. Traditionally, or typically, when we see an inequality that has just one variable, we would plot it on a number line. However, you will at times be asked to plot these inequalities on a coordinate plane. If you remember, x is equal to 3 is the line that passes through 3 on the x-axis. So I'm going to draw a dashed line that will pass through 3 on the x-axis. Since x is less than 3, that means I shade in all the numbers that are less than 3 for x. So you got to think to yourself, where are all of the x values less than 3? Would I shade to the right of the line or to the left? I can't shade above or below since the line is vertical, so I have to shade to the right or to the left. Well, since x is less than 3, typically I would go at 3 and shade to the left on the number line. That means I'm going to shade to the left on the entire graph. That indicates that all of these points to the left of that line have x values that are less than 3. Let's take a look at y is greater than or equal to negative 5. If you remember, if you have just a y value and no x value, you draw the line that passes through negative 5 on the y-axis. Since it's or equal to, it's going to be a solid line passing through, again, negative 5 on the y-axis. Since y is greater than or equal to negative 5, we just shade above the line indicating that all the points above this line have a y value that are bigger than or equal to 5.